So technically, your teacher in the first lesson has probably mentioned three types of quadratic expressions: quadratic trinomials, quadratic binomials, and quadratic monomial. Quadratic trinomial is the one that has three terms, a quadratic binomial has two terms, and a quadratic monomial has one term. In this activity, you are being told to classify the following quadratic expressions as monomial, binomial, or trinomial. So the key to identifying or to grouping these expressions in those groups is just to count the number of terms available in each expression. In the first expression, you have a square minus 4a. The number of terms is 1, 2. So this one is a quadratic binomial. This one is a binomial. In the second expression, number 2, you only have one term. Since there's only one term, this one is a monomial. Then in this third example, you have negative 3z squared plus 5z plus 2. If you count the number of terms, it is 1, 2, and 3. So this one qualifies to be a quadratic trinomial. Number 4, you only have one term, that one is a quadratic monomial. And then in number 5, you have three terms, quadratic trinomial. Number 6, you only have two terms, that one is a quadratic binomial. From explaining the types of quadratic expressions, the next step that you will go through is the process of factorization of quadratic expressions. In target book 3, when factorizing, we have to write the quadratic expression as the product of two linear factors. If you remember, we talked linear factors as those factors that when multiplied, they can give you a quadratic expression. For example, if you have 2m squared plus 5m minus 7, the linear factors of that expression are 2m plus 7 and m minus 1. The first term, 2m squared, is the product of 2m and m. If you look at our expression, if you multiply 2m times m, you get 2m squared. Then the last term, negative 7, is a product of 7 and negative 1. If you multiply negative 7 and negative 1, you get negative 7. The middle term is the sum of the product of 7 times m and 2m times negative 1. Okay, what they are trying to say is that the first and last term are the results of just products. All the middle term can only be found if you combine two products through addition. So if you are multiplying 7 times m and then add 2m times negative 1, it will give you the middle term 5. Factorizing a trinomial is in some ways a trial and error process. Let us look at the following examples to show the general approach. After factorizing, always check that the product does give the original quadratic expression. Okay, if you are trying to factorize a quadratic expression using this generic method, you find out that you'll be doing a lot of try and error. So to bypass that process of try and error, you basically have to do a lot of practice. Some of the, let's say, factors of the middle term will be coming in as natural instead of going through the process of finding the factors, finding the HCF or whatsoever. So the key to this to know the process of factorization is a lot of practice. For example, you have an example here to factorize x squared plus 10x plus 21. To factorize this expression, we are supposed to create two brackets where both of them will look like x plus a, x plus b, to give the term of x squared and the plus sign in the product. Now a times b will be equal to 21 and a plus b, that's the line. Okay, the process of factorization of this expression will go like this. You have x squared plus 10x plus 21. To factorize, to start writing the expression as follows. X squared plus 10x plus 21. It is an expression because it is not equal to 0. We have seen most of you doing the error of solving an expression which doesn't have an equal sign. Usual problems of factorization just require you to factorize without finding the roots of the equation. So if you are to factorize this expression, the first step is to multiply the first term and the third term. The first term and the third term. So we have to multiply x squared and 21, which will give you 21 x squared. After multiplying, you're supposed to find factors of 21. Those factors of 21, when you multiply them, they should give you 21, but when you add them, they should give you the middle term. So basically what you do is you go somewhere separate from the paper that you are using to solve the problem and do the primary type HCF. So you have 21 here, whereby you start with the smallest factor that can enter into 21. In our case, that would be 3. 3 into 21 will give you 7. And then 7, the next term that can enter into 7 is 7 itself. 7 into 7 will give you 1. So we are in luck here that we only have two numbers to deal with. In some cases, you find out that you are finding the HCF and it is continuous, like there are several 2s and 3s and 5s. So you have to struggle to find those two factors that can give you the middle term. But in our case, we're in luck. We only have 3 and 7. So basically, if you look at 3 and 7, 3 times 7, if you go to your multiplication table, 3 times 7 is 21. That is what we are looking for. And then if you do 3 plus 7, 3 plus 7 is 10. And that is what we are looking for exactly, because our middle term is also 10. So the terms that we'll be working with are 3 and 7. So you rewrite the middle term, like you rewrite the equation, but you rewrite the middle term in terms of the two terms that we have found there. So you have it as x square plus 3x plus